Okay, so we are going to use the calculator to find a scatter plot, find the equation, check the residual plots. Okay, so this video is basically how to use the calculator to do all these things. So I first have my data in list 1 and list 2. Okay, I want to look at the scatter plot, so I go second stat plot. I have plot 3 off, plot 2 off, I have plot 1 on. So I'm going to change plot 1 to my X list, list 1, and my Y list, list 2. That's where my data is. Make sure you're on the scatter plot, right? Then I'm going to hit zoom, and I'm going to go down to 9, zoom stat. It's going to recalculate your X and Y axis to where the data is in your calculator. And there is my scatter plot. Okay. Then we're going to describe it. Yep, and then you hit zoom 9. So this is as years increase, the birth rate decreases.
And that's just describing what?
That's describing our context, right? Remember that every problem on the AP question, you need to be talking about what the context of the problem is, which is what are our variables about, right? So if we just say negative, linear, which we're going to say those things, we're not talking about the context yet. So we're going to start by saying, what are our variables doing? As my X is increasing, my Y is decreasing, okay, because it's negative. This is one of the first negative graphs we've looked at, I think, right? So then we can say there is a negative, linear. It's pretty straight, right? I can draw a pretty straight line through there. Tightly scattered. Association between year and birth rate. We have talked about the direction, the form, the scatter, and there doesn't seem to be any real major outliers. Okay, with no apparent outliers. Okay, so that's what we are asked for if you're describing the association. Direction, form, scatter, outliers. Okay, and then that context statement, as X is increasing, what is Y doing? Letter B. You may have, so when you get an error, you can go to, and it'll show you what the problem is. The problem is, it doesn't know what to do with this weird thing here, so you're just going to hit clear, and then go back to zoom 9. Usually it's something you have to just clear out of your Y equals menu. You have too many plots open, and it can't graph them all in the same spot. Okay? Okay. So now we are going to find our regression equation. So my data is still in list 1 and list 2. I go to stat. I go over to calc. I go down to 8. Lin reg A plus BX. I tell it what my lists are. My lists are not female height and weight anymore. They are list 1 and list 2. I don't have to label them all, especially if I'm just doing a problem for one test. And then store regression equation is going to allow me to put my equation on the on the scatter plot. So I hit vars over to y vars, enter on function, enter on y1. I'm basically telling the calculator, create the equation, put it in the y equals menu for me under y1. There's like 10 different y's it can put in there, so it could graph 10 different functions at the same time. I always put it in y1 so that I'm replacing the old graph, whatever the last line was. Okay, and then I go to calculate. So here is my regression information. This is A, part B. Find the equation of the regression line. Write the model. Remember that this is the model. What's my y variable? My y variable is the rate, the birth rate, right? So rate hat, birth rate hat equals the A is my B naught. So 242.595. And my B is my B1 slope. That's a negative, so I'm going to make it minus 0.1142 year. Now you're going to get different numbers if you used 45, 50, if you did years since 1900, you're going to get a slightly different equation. It's not wrong. The difference is when you plug in, say you want to know the birth rate, you want to predict the birth rate in 1987. For my equation, I'm going to put in 1987. If you did years since 1900, you're only going to put in 87. And that changes our numbers a little bit because you're putting a much smaller number in. So that's my equation. Check to see if a linear model is appropriate. What does that mean? That means look at residual plot. I can't look at the residual plot if I didn't do the regression. My residuals will be the last lin reg that I did. So I have to make sure that if this is not in this order, and I'm asked for a residual plot, I'm asked is a linear model appropriate, then I have to do the lin reg before I can look at the residual plot. Okay, so I look at residual plot and scatter plot. I talk about both. So far, the scatter plot is linear. And let's talk about how to get a residual plot. A residual plot, I'm going to go to second stab plot again. Because I've already done lin reg, the residual list has already been created. I change my Y list. I go second. Above stat it says list. I always just go up because resid is usually towards the bottom. And I enter resid as my Y list. And then I hit zoom 9 again. Zoom. And I can either hit the number 9 or go down to 9. That's my residual plot. We have a question? You're going to have to be able to get through the whole calculator. What's wrong? Is something wrong? Okay. All right. So this residual plot has random scatter. This might be, that might be a little residual, like kind of an outlier. It's a bit farther than the rest of the data. But overall, our numbers are pretty small. If you hit trace, you'll find that your largest residual is 2.2. If you hit the trace button, it'll show you, let me just do it. If I look at my graph and I hit trace, it's going to tell me the value of all of those residuals. So my largest residual here is negative 2.2. So we're not too concerned. And if I go through, if I go through the points, we're not too concerned about that one being too far away. Okay, these are all very small residuals. So I don't really see a pattern, and I don't see, and I see random scatter, so a linear model is appropriate. So the scatter plot is linear, the residual plot has random scatter, no pattern, and pretty consistent spread. So a linear model is appropriate. It's important we answer the question. On the AP exam, if it asks you a yes or no question and you never address yes or no, the linear model is appropriate, the linear model is not appropriate, you get points taken off because you never actually addressed the question. You answered all things around it, but you didn't address the question. So make sure you're saying yes or no, or the linear model is appropriate either at the end or the beginning. Okay? But those are our justifications for the linear model being appropriate. The scatter plot has to be linear. The residual plot has random scatter, no pattern, and consistent spread. Part D, interpret the slope of the line. So our slope is negative 0.1142. Okay, so the slope, we use our cookie cutter statements. Our model predicts. For each additional year, and if it's year since 1900, we include that, we expect the birth rate to decrease approximately 1.1142. We don't need to say it's decreasing negative. The fact that it's negative means it's going to decrease by this much. Okay? They don't mark you down for abbreviations, but so it's okay either way. It says the table gives the rates only at intervals. Estimate what the rate was in 1978. So E, we're going to estimate 1978. And so we're going to plug 1978 into our equation. Rate hat. Now, if your equation is years since 1990, and I'm sorry, 1900, you're going to put in only 78. 242.595 minus 0.1142 times 1978. All right, we plug that in the calculator, we get 16.71. Okay. Then it says, in 1978, the birth rate was actually 15. F. In 1978 was actually 15. What is our, like how close did our model come? That's the residual. Okay, so it's, the residual is the actual 15 minus the predicted 16.71. So the residual is negative 1.71. Our model was 1.7167. Oh yes, 1.71 higher than the actual birth rate.